Good morning, everybody, to our second session on the chain rule, where we are going to practice some chain rule. Now, I'm just going to put the problem book questions on my other screen so I can see it and copy it. I think we can mainly we can see how problem 6.2 feels, and if there's anything else, I'll just make up questions as we go so that we can be sure we see everything that we need to see. Now we've done the chain rule, we've introduced the chain rule already, so this should not be your first session on the chain rule. If it is, then you need to go and watch the other video first. Today is all about just practicing. What am I trying to write here? I can't speak and write something different. Problem 6.2. Let's just start with number 1. Nothing wrong with a good old number 1. And I did not name these functions, which is probably a bad thing. A function should be named. Let's call them y. I have the following function, like so. Now, the very first thing to do, certainly, is to be able to very quickly and easily recognize when I'm working with a function of a function, when I'm working with a composition. There won't always be brackets to sort of give it away, but in most cases, there's some sort of bracket or square root or something containing something else, like in this case. So I will say, let us call that inside function u the obvious first guess, and then we'll see if that works for us. And if not, maybe I'll go back and see, was there another option? But this is the only obvious option that would work for us. Then, once I've made that choice for my inside function, the outside function, of course, is y in this case. Let's call it y, is 1 over u squared. These two things help me to say, so the derivative, and for the chain rule I use the little d notation. That helps me set it up. It's the derivative of the outside of the function with respect to the temporary variable times the derivative of that temporary inside function that we call u, to make things easier for ourselves. I can always do this, give it a name, set up the chain rule. You never have to feel that I need to not write any of this and jump right away to the answer. Some people are naturally going to do that, and some people won't. There is no downside to writing more. It's actually easier for me to grade and see that you understand how the chain rule works. So now I have two derivatives that I have to do one at a time. First one is the derivative of y with respect to the variable u. So for that I look at the square, the outside function. And maybe I want to see it as u to the negative 2 so that I can easily apply the power rule, negative 2 u to the negative 3. So now the second part of the chain rule says multiply with derivative of u is the function of x. That's the first line here, where u is a function of x. Let's check here. So for any small fraction with 1 on top, you can just move the bottom up like that. Absolutely I can, yes. Now I'll show you in a second here that you could have seen this as a fraction, a quotient, and use the the quotient rule, I guess let's just do that now. So it's going to be, if you want to use the quotient rule on this guy, it's going to be the derivative of the top, which is 0, times the bottom minus the top times the derivative of the bottom over the bottom squared. Then because of this 0, this whole thing falls away. And once I clean it up, I'm going to get the same thing. One u cancels with one of those. It's just complete overkill. Because the numerator is a constant, giving me this 0 in the quotient rule, it's completely unnecessary. It would work, but it's like it's a much more powerful tool for a teeny tiny little nail that you have to maybe hit. It'll work, but it's not necessary. So you do have options. So know your options. And maybe I've seen people go quotient rule every time because they're comfortable with that. Nothing wrong with it. The derivative is unique, so you'll always get the same answer. Now the second part is going to be 4x cubed minus 9x squared. Of course, though that part has multiple terms, so I need to remember the bracket. Now I have some stuff here, so I need to go on a new line maybe. Let's say here, finally, we are almost done, but we see in our answer at the moment we have a u. The u was really my choice. Someone else could be a little bit more comfortable with the chain rule and not explicitly write u equals x to the 4 and so on. They could still get the answer, right? So I can't leave my answer with a u in it. This was my helper, my choice to help myself. But it's not a big deal because I see what u is equivalent to. So I simply put back what u is, which is x to the 4 minus 3x cubed. And then I make the point to not change anything else while I am doing that. Separate that. Now if you feel, ooh, I don't like the look of this, I want to simplify, go right ahead. I am moving on to the next question because I have done simplification. It's a prerequisite. I know I can do it when the need arises. There is no need here because I have an answer. I personally find this maybe to be very simple, and making a fraction makes it look worse for me. So simplification is a subjective concept when I don't have a need for it. If there's a follow-up question, then I need to clean this function up in a certain way, sure, then I'll do it because I have a need. I have a purpose. There's no purpose, so then simplification becomes quite vague and sort of a personal choice. And my personal choice is to not waste my time. So I'm just scanning through the list here. Let's try number 3. We might as well see things in combination, properties in combination. While I think someone's typing, I'm just going to copy this guy down. 6 minus x squared. Make sure you have your square root covering everything it should. I see someone's typing. It might take a while. We can always just stop as we go. All right. Now, my question is, I need to find the derivative. What is the first property that I am going to apply in this case? The first one. There are going to be many properties. While you think about that, I will look at this question. Could we do an example where there isn't a bracket or a square root telling us we need to use the chain rule? Those are going to come in when we look at exponential functions, and we haven't done those yet. We need to add some new functions to our list of basic functions. They'll be the exponential functions. There you'll see there aren't really brackets. It's mainly those. Anything that is sort of polynomial based is going to have a root or a bracket of some kind. Unfortunately, there won't be many examples at this stage, but they're coming, so don't worry about it. At that stage, we'll be maybe more ready for it. So now back to my question, which property is going to happen first? So I definitely tend to focus on what's inside the square root, right? Okay, great. So let's do it. The tendency certainly is there is a bracket that's giving, not a bracket, it's a bracket type thing, the root, that is containing something. Certainly the chain rule is involved. The only obvious choice, the only choice I can make for my inside function is 6 minus x squared. Right? There is nothing else I could do because the root contains that. It's certainly inside. Then my outside function is what? Well, certainly the root of 6 minus x squared is going to become the root of u. Well, there's still an x here. Right? That x doesn't have any obvious way of being changed into a u. It'd be different if that x wasn't there. Then it's a straightforward chain rule. But that x is there. And now if I do this, you might think it's okay, but if I now go to my chain rule, that is ultimately necessary. It comes in two parts. I set it up. Now I look at what the first part requires me to do. It says you have to, not you, it says we have to see a y function with a variable u. But that's not what I'm seeing. I'm seeing a y function as a function of two variables, x and u. And we certainly do not have the skill to handle functions with two variables. That is, that's second year stuff. We can't handle it. We don't know what to do. It's not simple. Which means I am not ready for the chain rule the way I did it. I want to use the chain rule, but maybe the chain rule isn't the next property to use. I need to, just like if I compare it to this. Technically speaking, the power rule is not happening first. It's not ready for the power rule. I need to first isolate the portion that the power rule is going to work on. Now we get so used to this so quickly we forget what actually comes first is the constant times the function property. The power rule doesn't come first. We focus on the big properties and think power rule. That's not really what is happening first. It needs to be tweaked and moved into position for the power rule to then be applied. Yes, the power rule is a main player, but it needs to be ready. And it's not ready. Yes, the chain rule is a main focus here. But because of this x, it's not ready for the chain rule. It's just not ready. So here, let's say it. We're not ready for the chain rule. It's going to be there, but it doesn't mean it has to be first. Compare it to what we did with our basic properties. The power rule in the stop corner is there. It's not first. I have to get ready for it. So, this is not going to work. We're just not ready. Instead, we need to isolate that root so that when we get to it, it's just the derivative of the square root with no other x's floating around. I can't handle my outside function being a mix of x's and u's. It's not going to work. And someone might watch it and say, sure I can. Yes, but not at this level. With our toolbox, can't do it. Not in this setting anyway, I won't do it. So what can we do? Instead, we're going to use the product rule. I have other properties. Don't think, oh, I have this chain rule sledgehammer. Now, every nail I see, I'm going to use this huge hammer because it's so powerful. I can do everything. Yes, it might feel like that, but you need to set up the nail. It needs to be the appropriate situation. All right. So I'm going to use product rule first and say it's the derivative of the first part, because it's the product of two things, right? The first and second, times the second plus the first times the derivative of the second. And what the product rule is really doing, it's allowing me to look at pieces in this product in terms of finding the derivative in isolation. And I see here in the second part, I now just look at the derivative of the square root, and the x isn't there anymore. The product rule pulled it apart and allowed me to isolate the pieces. So now the derivative of x is just 1. You can write the 1 there to show that I have considered that. It didn't just disappear. And then x, and then this guy that I need to figure out. Maybe I want to do this on the side. Let's call this something else. Let's call it f of x equal to the root 6 minus x squared. Maybe I'm not ready to do it in one go, nor should you be at this stage, I think. So I need to go do it on the side. That means I need to rename just this portion. It's not the original function. I can't call it y. Right? Y was x times the root. I'm just interested in the root. So I call it something else. Call it whatever you want. Don't call it y. Then, so I'm going to say my inside function is 6 minus x squared. So I'm setting up the chain rule in the same way, but now I'm ready for it. Now it is just the root function. There's no x anymore. The product rule took care of that. I was just not ready initially. I know it's going to be there, but it's a timing thing. So the derivative of f, which is what I'm trying to find here, is, set up the chain rule, derivative of f with respect to u, derivative of u with respect to x. Now I can say, well, for the derivative of f with respect to u, I see f as a function just of u. Perhaps I want u to the 1/2. Perhaps I've memorized the root u derivative. I don't really know which one's better. I try and not memorize something, and if it happens automatically, great. At this stage, perhaps you'll go power rule. Perfectly fine. Then the derivative of u with respect to x, well, I see that up here. It's a negative 2x. Now, I don't love this dot next to a negative. I don't love it. Use brackets to indicate multiplication, because what people do, and I've seen it, but then I'm the bad guy when I don't know how to grade this. They make a dot, but it's so slight you don't even see it. You know it's supposed to be there, but you don't see it. Now, technically, I'm going to read this as 1/2 u to the negative 1/2 minus 2x, because that is what I see. Regardless of what you intended to write, that is what I see, and I can only grade what I see. But with brackets, there is no confusion. When in doubt, put more brackets in. But somewhere in school, they have taught people to minimize the number of brackets you use. That is nonsense. Brackets clarify what is happening. Use them. I just want to say that because then when this happens and I subtract marks, it's not on me. Okay, so I've done this. I can now go back here and say, I know I'm not perfectly done. I'm going to be finished in my line here. I know I need to replace the u, but I'm going to do it right now. It's going to be 1/2 u is 6 minus x squared to the negative 1/2 times negative 2x. Beautiful. Now let's just take a moment here and look at how long this answer is, how many things are happening here, and how far we've come in a short amount of time. I think it's impressive. I think we should celebrate that and be happy with how far you've come. Look at all this. A month ago, we weren't even close to doing something like this. Look at all this. I think we should be proud. Do I care to go further with this answer and simplify it? No. No. Personal choice. Personal choice. But again, we have to think, okay, what do I see? I look at the top function. I definitely see a function of a function, no doubt. But it's not completely pure. This x is messing me up. I might not be ready for the chain rule yet. There are other properties. Don't forget them just because you have this amazing, powerful chain rule. All right, so let's scan problem 6.2 to see what else there is. You'll see number 4 is similar. I just want to cover everything. We have time. I just want to make sure I cover what I want to cover. I think number 5 is a good one. Just want to get ahead of myself a little bit here. Not everything in 6.2 is chain rule requirement. Okay, just remind me, I want to do 24, but I don't want to do it yet. Ooh, actually 15 is nice too. Okay, what did I say? 5. Let's go with 5. 5 is good, yeah. 5 is good. Oh, not that page. Sorry, that's a mistake. Go over there. Thank you. I'll make a letter size. Letter size. There we go. All right. Okay, what did I say? Number 5, right? Problem 6.2. Number 5. Let's write it down. See what we have here. 1 over root 5 minus root x. It's very important to take a moment. Just look at it. Come up with a plan. Come up with a plan. What is the main thing I see? Okay, I see the root containing some stuff. So the chain rule certainly is in here. Now I need to decide, is it a chain rule right away? Am I ready for it? Is there other things happening? I don't know. But we need to think first and act second. Don't just go, and I'm just going to go. I've decided this is a chain rule question right away. Well, here it wouldn't have worked. So we need to think first. Okay. I'm not saying it is and it isn't. I'm just saying take a moment to think. Or you feel, okay, no, I think it's chain rule ready. Let's give it a shot, because previously we tried it and we saw the trouble that we ran into. There was a mix of x and u's in my outside function sort of stopping me. Then I could go back and say, okay, let's rethink this. That's fine. There's no harm in that. So let's give it a shot. Now there's a big square root, so I don't think it's a bad idea to try u as 5 minus root x. I think it's ready too. But I want to just emphasize that even if you're not 100% sure, trying it might show you better that it wasn't ready. You might not see it right away, but in trying the chain rule, something weird is going to happen. This mix of x's and u's telling you, oh, no, not ready. That's okay. And if that doesn't happen, well, then great. As long as my outside function is simple enough, right? Oops, not f. So the outside function in this case is 1 over root u, which certainly is simple enough because I'm going to write that as u to the negative 1/2, which again, I hope you are comfortable with. Then we're ready to try. We got an outside function. Outside function seems simple enough, so it's probably going to be good to go. Set up my chain rule. And if you're not sure how to set it up so quickly, just think of the fractions. They cancel and I get the original back. It's a little trick that I can use. Now, first part of the chain rule says, take the derivative of my function with respect to this inside function u. Oh, I see it right there. E z, u to the negative 3 over 2. Remember, it's always one less. Next part of the chain rule, derivative of that inside function. Now, maybe I am not ready for it. Maybe in some cases, the next one we'll try as well. The second part of the chain rule requires me to just take a moment and think, what derivative do I have to find here? That's okay. Don't care about doing it all in one go. You're not impressing anyone. You want to get the right answer. So it was too many derivatives for me at one stage. I handled the first one. Okay. Now I just need to think, perhaps, what does this u require? Because I see another root here. I'm just not sure. Okay, no, now I see. It's actually okay because it's just the root of x, which is x to the 1/2. Okay, I'm going to be okay. But it's okay to break it up into smaller steps. I now just copy down what I have so far. Now perhaps I'm ready for this second part, derivative, that I need to do. I'll emphasize it that it's 0 minus derivative of x to the 1/2 is just a power rule that I've done many times now. Now you're welcome to leave the 0, but maybe I'll clean that up a little bit. Maybe I want to write another line where I just address the 0. And then I want to take my time. Write as much as you need to. Then I remember, okay, I just need to address the u, get rid of it to have my final answer as negative 1/2 5 minus root x to the negative 3 over 2 times negative 1/2 x to the negative 1/2. I don't even merge those two negatives. I do nothing else but replace the u with what it means. Some people are bothered, oh, but you have a fraction power and then you have roots. Shouldn't you rewrite everything to roots or everything to fraction powers? I don't care. I don't care. It's just different versions of the same thing. And I'm comfortable with fraction powers and roots to mix and match them as I want to. It doesn't matter. They're the same. Again, the simplification is up to you. So in this case, yeah, it was fine. I thought it was ready. I tried it. It was ready. Perfect. No problem at all. Well, not no problem. There were some things happening, and I need to perhaps practice more and think about it for sure. Okay. Just want to think, what is the next one I want to do? I want to do something like 24, but I don't really want to do 24. nothing wrong with it. I just don't love it. I want to get the best examples to illustrate the different things we need to be aware of. So we've seen the chain rule a couple of times. We've seen that the chain rule doesn't have to happen first. There could be another property. Let's see how this one. Ooh, I like 23 as well. 23 is nice. Let's do 23 first. We have the time. I can do both. Problem 6.2. My writing is horrible. I'll do 23. Y equals 2x plus 1. Maybe I'll just do 23, 24 as they are. I don't want to get too clever here. There's nothing wrong with them. The exponents here are just a little low, making me think I can simplify, I can FOIL this out and simplify it first, and you certainly can, but it'll be much more efficient to go to keep them as functions of functions. Be way more efficient. But again, I have a clear bracket with an inside function here, as well as here, and they're not the same. Telling me that the chain rule is not ready. It's not ready. That's okay. The product rule will get it ready. Derivative of the first. And again, I'm not ready for this derivative maybe. I just want to write down what I still need to do. Times the second plus the first times the derivative of the second. I'm not ready for it. I'll look at it later and think what needs to be done. Okay. People make mistakes often because they want to write the answer in one line and be done with it. Well, there's a lot of things happening here. And if I try and do all this in one go, there's a lot of things I have to keep track of in my head, and things are going to get mixed up in there. Write one thing at a time and then look, okay, what do I need to do? I need to do this derivative. This requires a chain rule. Later on, this will require a chain rule as well, but a different one. So I have two different chain rules that need to be done. So let's maybe do that now and then come back to what the original function's derivative is when I put everything together. So now I have two small chain rule questions. Now you might still need to define an inside function. Let's call it u, the obvious 2x plus 1. Then I'm just going to call, let's call this, call it f. Oh, I said f, but I didn't write f. Let's call it f. And we'll call this one later g. I can't call them y. Y is this original function. So f is then u cubed. And so my derivative of f, maybe I'll write the little d notation consistently, is, by the chain rule, df du du dx. Write it in. Derivative, they're all straightforward, basic property derivatives, right? That is a dot. And I can replace the u, but I'll just do it in the line for my final answer. Don't feel like you have to stop writing all of this. Maybe down the line, you'll start to write less and less as you become comfortable. That's okay. Let it happen then. Don't force it. This one maybe. Let's call it the inside function v. I can't use a u, right? I've used u already. It's a different inside function. Then g is v squared, still pretty straightforward. And so my chain rule is helping me find the derivative of this g portion as the derivative of g with respect to my inside function times the derivative of the inside function with respect to x. Clearly just a 2v times 2x. Quite straightforward. The product rule helped me to isolate the pieces. So now I am ready to say, well, the derivative that I was actually looking for is 3 2x plus 1 squared times 2 times this bracket, x squared plus 1 squared, plus this bracket over here didn't change, 2x plus 1 cubed. The derivative now is 2v, and v is x squared plus 1 times 2x. Look how long this thing is. But I do it little bits at a time. Then no single step is overwhelming. No single step is ever overwhelming. When you zoom out and look at the whole thing, imagine having to go from the original function straight to this last line without writing anything else down. Maybe you'll be ready for it. Maybe you're ready now. But probably not. If you force it, you're going to make mistakes. Maybe down the line, you feel more comfortable doing that. Go right ahead. But help yourself where you need the help. It's okay. It's okay. Right, we have time. Let us do 24. Problem 6.2, number 24. We've pretty much seen everything that there is. This last one is worth highlighting. Oops, my threes are not looking good today. 3, like so. Now, that they're both -1 is a little unfortunate, but whatever. I clearly have brackets, so I clearly see a function of a function. What are my options here? I have options. Option 1 is to let u be 2x plus 1, like that. Okay, I have more than 2 options, but I have some main options by focusing on the brackets. Or to let u be what's inside the big bracket. It's pretty safe to let the brackets guide me at this stage, right? Those are based on the brackets. Those are my 2 options. There are other options, but they're not going to be any better than these. In the first case, then y is going to be u to the -1 plus 3 all to the -1. Even if I make that a fraction, it doesn't actually matter too much. In the second option, y is going to be u to the -1. Neither one of these is wrong, but we said we want to move forward with the choice that has the simplest outside function. By simplest, I mean I can find the derivative with basic properties. And the first one does not qualify, does not have that. This outside function is another chain rule. Or you could maybe argue that, okay, well, I could do this with it. So then it's a quotient rule. Okay, yeah, still not nearly as simple as this guy. So if you want the challenge, you can go for the first option, but I'm always going to go for the simplest outside function. It's going to save time. It's going to be more efficient. It's going to look better. Everything's just going to be better. It's not a question of right or wrong. It's a question of preference and having a smoother path and an easier, better experience through this question. Not right or wrong. I'm going to prefer, oops, I'm in eraser mode. I'm going to prefer this. It's not right and wrong. That's my choice. You're happy to try, you're welcome to try the other one. You'll still get the right answer. It won't look the same, but it will be the same. So I'm going to go with this one. So now, the derivative, setting up the chain rule, I'm not ready to not see this setup. I need to still see it. I'm going to still see it. The derivative of the outside function, hopefully you'll agree, very straightforward. Power rule. It's ready. It doesn't even have any other property. Times the derivative of u. And now I see that, oh, this u function does not look great. It doesn't matter. What matters is that I address the outside function quickly and efficiently. If that outside function is complicated, nothing good is happening. You're welcome to try it. And in this case, it's still doable. It's still doable. It's okay. A quotient rule isn't the worst thing ever. But if I can avoid it, I'm gonna avoid it. So now you see, okay, I wasn't ready to just write in what the derivative is. I need to see it first. Okay, it's not a big deal. Now when I look at this, I see, oh, this requires another chain rule. Look at the brackets. That's not a big deal. I can just call this something. And people are very, let's call it G. People are very hesitant to do things like this. Just scribble some stuff on the side and say that inside function, let's call it V because we've used a U. Whoa, that was ugly. Let's use a V and call it 2x plus 1. Then this little function, not my original, is v to the negative 1 plus 3. That's simple enough. So the derivative of this g function, which is what I still have to do, set up the chain rule, see it, check the fractions, make sure it's right. I don't know if I have space for this. I might. Derivative of g, it's basically the power rule, right? There's a sum property and a constant property, sure. But all that's left is really the power rule. Times derivative of the v function, 2. I'm now ready to put this in. Now, perhaps I'm not ready to do all of the replacements. Just want to finish this derivative. That's okay. I need to put back what v is. I'm going to use nice big brackets here because I don't want to get confused with a dot next to a negative. It's negative v 2x plus 1 to the negative 2 times 2. Because I've scribbled some stuff on the side, I'm now sure of this answer. Yes, I still need to replace what the u is. U is up there, doesn't look great, I agree. Nice big brackets. 2x plus 1 to the negative 1 plus 3 is what u is to the negative 2. None of this looks good, but that doesn't matter as long as it's correct. And there we go. Yes, it's all the negative exponents that's messing me up in terms of having it look nice. But I have the skill in simplification, and if I really wanted to, I can clean this up by moving this below the line and this below the line and putting them together. It's never going to look right. It's never going to look wonderful, regardless. If you use the first option, sometimes it's not even doable. Sometimes I don't even want to mess with it. But a quotient rule would get the job done. It's not going to look much better than this. It's going to be messy regardless. So what I will slowly get used to is looking at this original function and seeing sort of a chain rule inside a chain rule. There's a chain rule here, and then there's a chain rule there. But I don't ever do them at the same time. I focus on keeping the outside function simple, making whatever choice for you I need to make in order to have that happen. And then when the time comes and I need to look at the derivative of that insight function, I'll then reassess. What does this require? Oh, it's another chain rule? All right, let's do it. But I'm still looking at these pieces in isolation, one little thing at a time, constructing the final derivative answer to be something that doesn't look good. This does not look good. I don't like how this looks at all. But that's not the problem here. The problem is, how do I piece this together correctly? Working with this for a future question, okay, well, that's a messy simplification that I have to do. But that's not the question here. The question is, how do I isolate pieces to construct this derivative? Doesn't matter how bad it looks. So there are some things to think about, practice to be had. Now, the issue of the chain rule will come up again. These properties will come up again as we introduce new functions. Then we revisit these properties in combination with things we've seen. So it's not that, oh, I have to master this right now completely. We'll be practicing these things as we go as well. It's just a matter of taking the right approach. Look at the function. What property comes first? Getting used to approaching it in the right way. If it's not perfect right now, that's okay. We're going to practice a lot more as these things come up again and again.